Okay, so now we're going to talk about z-scores. So in the previous section we introduced the normal distribution and we talked about these percentages that lie within certain intervals in the normal distribution. And this is all fine and dandy, but what if the value that you're looking at is in between these intervals? So as an example, let's say if we're looking at a score of 119, 119 would be about like right here, right? Between 115 and 130. It's not right on the 115, so I can't say exactly what percentage it's going to be just by looking at these numbers here, right? Okay, so what I will have to do is to find out exactly how far away this 119 score is away from the mean. The mean, of course, is 100. Standard deviation is 15. So what the z-score does, it tells you how many standard deviations you are away from the mean. So if you calculate your z-score to be, say, 1.24, this means that since it's positive, you're above the mean, and you're 1.24 standard deviations above the mean. So you would probably fall like around here, okay? Whereas a z-score of negative 0.82 would be, since it's negative, it would be below the mean, and at 0.82 standard deviations below the mean. So that would be somewhere between this area here. It's not quite one standard deviation below the mean, so it might be like around here, right? Okay? So if I want to find out how a score of 119 compares, I can use the z-score formula. So here x stands for the data value of interest. This is your mean, and divide by your standard deviation. So to calculate my z-score, I'll take my score of interest, which is 119. I subtract my mean, which is 100. Then I divide by my standard deviation, which is 15. So 119 minus 100 is just 19. Divided by 15, which gives me about 1.266, etc., right? So if I were to round this to 2 decimal places, it would be about 1.27, right? So now, what I can do is I can go to my textbook, and I can go to page 580 to 581, and what you'll see is called a z-score table. Let's see if I can fit this into the camera here now. So you see it's got 2 pages. One side has negative z-scores and the other side has positive z-scores. So now how this table works is it tells you, if I know my z-score, in this example here it's a z-score of negative 1.15, then the number that's in here when you find a negative 1.15 tells you what percentage of the data is less or below that z-score. So in this case, I need to find this z-score in the table. So negative 1.15. So I take the first 2 digits and I find them here. So negative 1.1 is right there. Then I need to find the 5, which is up here. And then I just come down to where they meet. Well, they meet right here. So this gives me 0.1251. This tells me that 12.51% of the data are less than or to the left of this score, whatever that score is, right? Okay. So now in that example, we found a z-score of 1.27. So since it's positive, we're actually going to be on page 581, the positive values, which are here, right? So 1.27. So I look for 1.2 downwards first. So here's 1.2, and then the 7 is right there, right? So I've got 0.8980. 0.8980. So that tells me that 89.80% of the data are less than this score that I'm looking at, the 119. So To answer the question, how does a score of 119 compare to the rest of the data, I could say that 119 is higher than 89.80% of the population. Okay? So that's how a z-score works.